The next topic in additional mathematics is surds. Okay, so a radical is any number which is with the radical sign, meaning the number must be under the radical sign. A surd is a real irrational radical. So surds are present in solution to some quadratic equations. So it could be root 3. So the next point states that every surd is a radical, but every radical is not a surd. I'll explain right away. So, for example, root 9 is not a surd because it can be simplified to 3. It must be irrational, meaning it cannot be written in the form p by q, where p and q are integers and q is not equal to 0. It cannot be represented by that, but then 3 can be. It's basically 3 by 1 or 6 by 2. So therefore, it's not a surd. It must be irrational. And the next point is that it has to be a real radical, meaning you cannot have square root of -1. That would be not real because we still don't know the value of square root of -1. And the next point is that square root of a is a non-negative number such that square root of a into square root of a, meaning square root of a whole squared, it's equal to a. So that's the whole thing. Just remember that this is very important. Every surd is a radical, but every radical is not a surd. So radical can be irrational or rational, but a surd has to be an irrational radical. Okay, now let's do some properties of surds. So square root of a is greater than or equal to 0, and hence it cannot be negative. As we clearly know, square root of something has to be positive. And square root of a is only real if a is greater than or equal to 0. If it's a negative number, it would be an imaginary number. Yes, so it has to be greater than or equal to 0. And square root of a into b equals square root of a into square root of b. This is the property where a is greater than or equal to 0 and so is b. It must be greater than or equal to 0. And the next thing is that square root of a plus square root of b is not equal to square root of a plus b. So for instance, I'll just give an example. We'll take square root of, let a be 2 and b be 4. So square root of 2 plus square root of 4, I'll just tell you the answer. Square root of 2 plus square root of 4, that is 3.41, and square root of 6 is 2.44, meaning they're not equal. So therefore this property states that square root of a plus square root of b is not equal to square root of a plus b. And the next property states that square root of a divided by b equals square root of a divided by square root of b, where a is greater than or equal to 0 and b is greater than 0. So here it must be greater than 0 and not be greater than or equal to 0, because square root of 0 would be 0 and something divided by 0 is infinity, or in other words is undefined. So yeah, so b must be greater than 0. Yeah, so now I have solved a few examples here. So square root of 15 into square root of 4, we know this one, it's this property. And now we can multiply these two, meaning it's square root of 15 into 4, that is square root of 60. We can simplify this further, but we'll just leave it like that. And then we'll solve this also. Square root of 36 divided by square root of 7. So square root of, so this would be square root of 36 divided by square root of 17. It's because of this property, so that would be 6 divided by square root of 17. So you could remember all the squares, the numbers and its squares, like 1 is 1, 2 is 4, 3 is 9, If you really want to save time, like maybe a few seconds, then you could do it. Or I mean, you always have a calculator, right? So it doesn't really matter. But then if there are like no calculator questions, you might find it a little difficult because you'll have to like manually multiply it. Like if it just say square 21 or something, then it might be a little difficult. It may be time consuming. So if you want, you could remember it, or else it's fine. So now you will have to solve these. I'll just solve maybe one of them. I'll solve this one. No, actually, I'll solve the third one. So the question states that square root of 21, you could also write this, square root of 12 into square root of 21 divided by square root of 4. We know that square root of 4 is 2 because 2 squared equals 4. So that would be square root of 12 into 21 divided by 2. So I've used one of the properties, and 12 into 21 is 252 divided by 2. We could simplify this. You can just use a calculator, and we get 6 root 7 divided by 2. So basically how we got this is we could write this into 36 into 7. We could split this down. We could write 257 as this. And then we know the properties. One of the properties is square root of 36 into square root of 7. This equals this. And we know that square root of 36 is 6 into square root of 7. So this, we have used one of the properties. Yeah. And we could cancel this out, meaning 3 root 7. So this would be our final answer. Yeah, or we could just leave it like this. I mean, either way is fine. But so that would be square root of 9 into square root of 7. So that would be square root of 9 into 7. That's square root of 63. These two are equivalent. This one equals this. Either way is fine. Each of the answers is fine. And the rest of the answers would be easy. Square root of 11 into square root of 11, that's 11 itself. And you just have to multiply these two.